Welcome to this presentation discussing developing number sense. In this presentation, we will discuss why developing number sense is an important element in a well-designed developmental math program. We will review skills that help develop number sense and present several methods for teaching those skills. Counting is a skill that appears to be easily acquired at an early age, yet many confuse counting with more advanced ways of thinking. For example, just because a child can count does not mean that the child can look at a numeral and tell you what it is. Counting out loud does not mean that students can write numbers or match a number to a set of objects. Counting does not mean that children know that 5 is less than 9 or that 400 is less than 4,000. Counting does not mean that children understand that 15 is closer to the number 10 than it is to the number 50. Just because a student can count does not mean they understand what a number is or what it means. When we look at all of these skills put together, we are really looking at how a child develops number sense. What is number sense? Number sense is the ability to use common sense about numbers based on the way numbers and measurement tools work within a culture. So why do we need to help students develop number sense? Having number sense helps students develop an appreciation for the reasonableness of an answer. Students with good number sense are more able to detect errors in their work, and number sense helps students choose a logical way to approach problems. People often confuse number sense with counting because counting is one of the first skills we develop. But counting is only one component of developing number sense. Children need to know the order of the names of numbers so that they can assign names to sets. We can develop counting through everyday experiences. We teach children how old they are. We use counting in cooking, and in everyday life things often come in pairs. For example, we count 2 shoes, 2 eyes, and 2 slices of bread on a sandwich. Children also learn to count through nursery rhymes such as 1, 2, buckle my shoe, other songs, and books. However, children are not just able to learn to count. There are some prerequisite skills for developing more advanced counting skills. First, children have to learn the stable order rule. This rule just means that counting words must be used in a certain order. After children develop this skill, they move on to the one-to-one rule. This rule is where children learn to say one word for each object. We also call this counting with one-to-one correspondence. When children are able to master the standard order of numbers and keep track of the total as the last number named, this is called the concept of cardinality. For example, when a child can tell you how many after counting a set, they have developed the concept of cardinality. Finally, we have the abstraction rule. This is just when children understand that we can count objects even if they're not the same. While preschoolers may be able to count, they may not be able to compare 2 different sets. Answering questions such as, "Are these 2 groups the same?" may be more than they are able to do. Researchers have found that when students are comparing 2 sets, they will not match sets of objects with one-to-one correspondence until around the age of 5.5 years old. And students will not use oral counting as a strategy to determine whether or not the sets are the same until around the age of 7. What does this tell us? It tells us that even though students know the names of numbers, they may not know what numbers mean until they are about 7 years old. Cognitively guided instruction is an approach that teachers can use in the classroom to address a myriad of math skills. Teachers who use cognitively guided instruction describe 3 levels of counting. First, there is direct modeling. This is where the child must physically touch and move the counters in order to arrive at a number. Secondly, students develop counting strategies. In this, students are able to think about part of the problem as a starting place and count on or count back from that number. A third state is called derived facts. This is when children are able to use number facts or easily memorize facts to solve the problem. Through preschool, kindergarten, and much of first grade, children rely on direct modeling. In kindergarten, children develop the concept of one more, one less, and they begin to develop more complex counting strategies, and these continue as they progress through the grade levels. The mathematic learning standards define the grade levels at which children should be fluent with facts. This means that they are not relying on models to solve facts. Students are not expected to be fluent with facts in the preschool level. According to the standards, they should be able to add and subtract within 5 at the end of kindergarten, within 10 at the end of first grade, within 20 at the end of second grade, and add and subtract within 100 at the end of third grade. Children also develop number sense through the use of nominals. Nominals are simply numbers used as nouns or descriptions. We see these in everyday life. For example, we ride on 747 jets. Football players are often called by their jersey number, such as number 43, or children refer to the clothes they wear as size 6 clothes. Using nominals helps expand a child's vocabulary. Number sense cannot fully develop until children develop the concept of conservation. Conservation is defined as the ability to keep in mind what stays the same in an object and what changes in an object after it has been changed aesthetically. When we look at this concept in relation to other math concepts, it means that 7 objects will always be 7 objects, whether they are lined up in a short line, a long line, a circle, or any other shape. We can test a child's conservation abilities by showing them 2 rows of items that are the same. Then we can take one row, spread it out, and see if the child still sees these items as the same. We know children are still developing this concept when they insist that a taller glass will hold more water than a wider glass. So what does this mean? It means that until children have developed the concept of conservation, number work and counting will be purely mechanical. Asking children how many or how many more will be reasonable tasks, but asking a child to compare situations such as, there are 6 children and 4 candy bars. How many children won't get a candy bar if each child gets one, may not be appropriate for children who have not fully developed conservation. Just because children might not have the concept of conservation does not mean that classroom activities with numbers should wait for children to develop this concept. Rather, there are many developmentally appropriate ways to teach counting and number concepts with young children that will further their mathematic understanding. It is important to make these activities engaging and active experiences. One of the most important advances in early childhood mathematics research is the finding that many teachers skip the essential building block of developing part-whole concepts of numbers. Previously, teachers would teach children to count, recognize numbers, and attach a number to a set. Now we know that children will develop better math concepts if we teach them how to count on and count back, as well as create and talk about parts and wholes. Part-whole activities involve exploring a number as a series of subsets, which when combined equal the number. For example, the number 6 is the same as saying 2 plus 2 plus 2, or 2 plus 1 plus 1 plus 2, or 3 plus 2 plus 1, and so on. In the past, we taught students based on the place value system. So when we asked them what numbers can be used to make up the number 42, students would reply 40 plus 2. However, when we asked them to do it a different way, students were not readily able to do so. They couldn't come up with an answer such as 39 plus 3 or 21 plus 21. Japanese children are encouraged to compose and decompose numbers at every grade level. Doing so develops part-whole concepts. Developing part-whole concepts of numbers helps children to be flexible in their thinking about numbers, as well as their approaches to problem solving. Helping children to think in groups is another way to help them develop number sense. Thinking in groups involves seeing small sets of objects without having to count them. This concept is developed by activities of counting on, such as starting at 5 and counting up from this point, counting back, starting at 5 and counting backwards from here, and part-whole experiences. Many teachers develop this thinking in groups by using dots on plates. The children can see the dots and then name the number as fast as they can without counting. When using dots on plates with larger numbers, teachers can ask the children what patterns they see within the dots. For example, if there were 9 dots on the plate, the child might say that they see 3 groups of 3. Another method of encouraging children to recognize number sets is to use 10 frames. A 10 frame consists of 2 rows of 5 cells. The child can fill up the first row of 5 before moving on to the next row of 5. The 10 frame method reinforces our natural tendency to do mental calculation from 5s and 10s. These materials strengthen a child's sense of relations between numbers, especially the benchmark numbers of 5 and 10. An example of a 10 frame is shown on this slide. Children also develop number sense by learning to read and write numerals. Numerals are the written symbols of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. In kindergarten, children develop an awareness of the name of the symbol and its number value. To learn to read numerals, children can play games like concentration or bingo, as well as rolling dice. When children are ready to learn to write numerals, there are a variety of mediums teachers can use to break out of the traditional worksheet mode. These methods, listed on the slide, can be very engaging for children. While young children are not expected to work with and master the use of fractions, the National Council for Teachers of Mathematics Standards recommend that children develop an understanding of basic fractions such as 1/2 or 3/4. When children are beginning to develop an understanding of fractions, it is important that they also develop the concepts of partitioning and equivalence. Partitioning is sharing equally, and equivalence is making sure that each partition is the same. For example, when children are given 2½ crackers, they might say that they have 3 crackers. This means they do not yet grasp the concept of making items the same. As they develop these concepts, their number sense will improve. They will not be able to understand that numbers represent equal units or intervals until they develop number conservation. Teachers can help students develop the concepts of fractions by using part-whole relationship models. Many times, this is seen by teachers using regions which have shaded parts and unshaded parts representing fractions. This can be done on paper or with objects such as Unifix cubes, as shown here. While working to develop number sense in children, we need to consider that children are fascinated by big numbers. We can help foster children's understanding of large numbers through books, estimating, and comparing activities. The books How Much is a Million by Schwartz and Wangari's Tree of Peace, A True Story from Africa by Winter are excellent examples of books that teach about large numbers. As a side note, whenever we choose to use picture books that include numbers, we need to make sure the pictures accurately represent the numbers stated in the book. For example, in the book 10 Apples on Top, when the author states 4, there are 4 apples on the lion's head. Using books with inaccurate representations can lead to confusion in our children. As we have discussed, developing number sense is an important element in a well-designed developmental math program. However, you might not see these concepts in place in all early childhood settings. These concepts may be new to teachers, even the most experienced teachers. As early childhood educators, we need to pay attention to how young children think about counting and numbers. Then we must design experiences that guide development of concepts and skills in these areas.